Hello, and welcome to Canvas 3D tutorial with 3JS. Today we are going to use the new Canvas element in HTML5 to draw 3D graphics using the new JavaScript library called 3JS. First, we will create a blank HTML5 document. We'll just go ahead and give it a title of Canvas 3D tutorial. Next, we will style the canvas element, which hasn't been created yet. We want to set its height and width to 100% so it'll always be as large as possible in the window. Finally, in the head of the document, we want to load two scripts. The first is the core of 3JS, which contains all the code we need for working with Canvas. You can download a complete 3JS copy at 3js.org. After you've done that, you would place it in your project folder and link to it like so. Second, let's link to a JavaScript file we'll call canvas 3D.js, which will have all our code for generating objects. Finally, we want to put a call to our function canvas 3D, which will be in our canvas 3D.js file. This will be a function that serves as a wrapper for all the code we want to execute in this program. And we'll add it as a function call between some script tags. Next, we will create our canvas 3D.js file. We are going to do a simple 3D ball court with a bouncing ball. First, we will create our function canvas 3D to contain all of our code, like so. Next, we'll create 5 functions: init, draw court, set speed, render, and movement. So we have init, then we do draw court, set speed, render, and finally, we have movement. Before init, let's set up our variables. Scene, camera, and renderer are the vital components for displaying our 3D. Geometry and material are used to make our meshes, which actually show up on screen. Our sphere will be the bouncing ball, which we will place in a ball container. Court will be the object with our court geometry. X speed, Z speed, and Y speed control our ball movement. Court width and depth are dimensions of the ball court, whereas Z position court, Y position court, and court top control where our court appears in space. Next, we will set up the init function. What we see rendered is a combination of two things: the scene and the camera. The renderer is a WebGL element, which is a JavaScript API for 3D graphics. This is a built-in browser capability. We set the size and add the renderer to the document. This creates our canvas. Next, we need to add some geometry for the ball using the sphere geometry method. Next, we need to create materials to go with our geometries. We are going to have two for the ball and court. We will use the mesh basic material method in 3JS, which is just a simple color surface. We'll do a gray for the court and set its wireframe to true so we just see lines, and we'll give a reddish color to the ball and set its wireframe to false so we have its surface show. Next, we create the sphere by calling the method for a new mesh, and we pass the desired geometry and material to it. We will also set the initial position of the sphere. It's X, Y, and Z. Now we use the Object 3D class to create two containers, one called ball and the other called court. We will add the sphere to the ball container, then we add the ball container to the scene, which is like adding something to stage in Flash. Next, we will draw the court. First, we will give the court a width and a depth. We want the court to start at the origin, so we set Z position to 0. The Y position will be -10, so that the bottom of the court appears below the center of the camera we'll set up later. We do that by first setting court bottom to -10 and Y position equal to court bottom. We are going to have a height of 20 for the court, and we set the Y position of the top court surface to initial Y position plus court height. Next, we will create a simple for loop to run 2 times. We are going to draw the court using shape. We start at the origin. Then we go clockwise and end back at the origin. Before we can display the ball court, we have to add the shape to a shape geometry. After we've done that, we can combine the geometry and material into a new mesh for our ball court. We center the ball court by dividing the width by 2 and converting to negative. Right now the ball court is standing vertically. We want to lay it flat, so we rotate it away from the viewer 90 degrees. Angles are measured in radians when it comes to rotation in Canvas 3D, and there are 2 pi radians in a circle. So to rotate away from the viewer 90 degrees, we do 2 times math pi times negative 0.25, which basically gets us negative 90 degrees rotation. This lays the ball court flat, stretching away from the viewer with one end at z equals 0. We next add this mesh to the court container, increment the position by 20, and do one more court surface. Finally, we set the camera position. We set its Y to 0 so that it is midway vertically between the court surfaces, and we set the Z position to 20 so that we are positioned somewhat back from the start of the court. Also, above the camera position settings here, we've added the court to the scene. Now we need to set the speed variables for the ball. Every time the screen redraws, this determines how the ball moves. We'll make the X and Y speed random numbers between 0 and 1 by using the math.random method in JavaScript. Z speed will be fixed at 1.3. This entire function will only run once. Next, we have the render function. Now this function, once executed, is actually an animation loop running at 60 times a second. We are going to have 3 components. One is request animation frame, which takes one argument, render. Next, we have the movement function. Finally, we have the renderer, and we call .render with 2 arguments, scene and camera. This uses WebGL to create what we actually see in the canvas. The movement function is where we define how the ball is drawn every frame. Since ball has only one child, which is the sphere, we access its position using dot notation, just like with DOM manipulation. Every Object3D object has a children property, which stores info on everything it contains. We want to access the position properties of the ball, and we animate it by adding the X, Y, and Z speed to the position every time we redraw the canvas. The last thing we need to do is keep our ball from flying off the screen. We do this by setting bounds. First, we know we want the ball to stay within the width of the court, so we set up an OR conditional so that if the X position of the ball is greater than the right side of the court or less than the left side, we multiply it by -1 to make it reverse. We do the same for the Y and Z position of the ball as well. If the Y position of the ball exceeds the top of the court or the bottom, it reverses. If the Z position of the ball is less than the court depth times -1 or greater than the Z position of the court, which is 0, we reverse it. To finish the setup, we call the init, draw court, set speed, and render functions. Now, as you can see here, we have the result. When the ball hits any bound, it reverses direction. So when it hits either end, it reverses. When it hits the side, it goes back to the other side. When it hits the bottom, it goes back towards the top.